Hello everyone, this is Caplitero. Welcome back to a new episode. Today we're gonna talk about uh, value noise. Something like Berlin noise, but easier. And there are not so many calculations to do by the computer. Let's start by creating a new SFML. Let's call this volume noise. I should have said value, but yeah. Let's rename this to value noise. Okay, so I'm gonna start like usual with checking if program works. Starting like usual. Okay, now let's create a new header file with noise class of value noise. Okay, making this bigger so you can see. Public with a constructor. Say x, let's say width, sign and height, width, height, and anything else. I don't think so. Okay, now let's create the seed array float of seed. Okay. Let's also add a sign and of width, sign of height. Let's say width equals width, height equals height, and that's all. Oh, you see the array and the output. We'll need to set load of width times height. Output, it's the same size. Okay, now let's generate a new map. New seed. 0 size, no, width, height, a plus plus. Seed equals load rand include stream divided by float of rand max. This will give values between 0 and 1 to every point inside for the seed. What we're gonna do, let's show you. We're gonna have this is the screen, and it will be divided in squares of the same size. We'll call this pitch. This will be the pitch, and um, uh, sorry, the pitch. So the values are set on the in the corners for every seed point. Now, every other point between will get a value close to the corner. So how we do that? Let's say we have a Berlin noise, call this void noise 2D. And x equals 0, x with x plus plus equals 0, I height I plus plus. Okay, so what's the size of the pitch? Let's say that we want the pitch to be this size, or maybe the half of the screen. Say int pitch x, size of x, oh no, width divided by 2. This will be the pitch, and pitch y equals height divided by 2. We can actually make this a value. We don't, doesn't matter if it's 2 or 4 or anything else. Now, let's see, int of x0 ends the first corner of every grid. This is x0, 0, 0. So x divided by pitch to get the corresponding tile. And now times of pitch to get to the actual place. This is id1 equals 0 times pitch will be 0. This is id2, and you can get it. Actually, it's id0, id1, and 1 times pitch. Now, we'll do the same with I divided by pitch times pitch. Now we'll need to get to the next one. So I x1, I1. x1 equals 0 plus pitch mode width. Because if we get to the last one and x1 actually it's outside, we can go nowhere and we'll return to the first grid. And that's the same for I. mode. Now we need to get the weight. Nice. Load I minus I0 by pitch. All of those you can go into linear interpolation. Here, let's say, and linear interpolation. You can see. Oh, 1 second. X minus x0 divided by x1 minus x0, which is the pitch, is the area between x0 and x1 and x0, the length of the space between them. Okay, now we got this, we need to find I. This is actually z, because we are into the finding a new z. And now we go for float. C1 equals seed of I0 times width plus x0. Is the same. X0, y1, and x1. Load of final x equals to lerp of z1, z2, tx. Load e equals lerp of z3, z4, dy. What is lerp? It's a function. It's float lerp float x1 x0 float x1 float weight. And this will return the linear interpolation. Return 0 times minus weight plus x1 times weight. Hope it's the good one. Lerp. We'll go back to our function and say that noise of no, noise, let's say output of time times width plus x equals a I minus x plus x This is all. In minutes, I don't think I actually have time, but let's vertex from vertex array map. Let's say set primitive save points map that set resize width times height, and now for every update, this is the update, we'll say void show map, and for window get size y plus plus window get size of x plus plus. Index will say x plus I times width of game. Let's actually int hash x game map is the problem. Map of index position equals as a vertex of y. Map index point color equals, and have a noise. Did I call it value noise? Of width times height, and now new gen and let's say form noise 2D. Noise transform. Let's see. Noise SF color of and times noise output of index. I just forgot one thing. Here we're gonna have window draw map. Here was the Primble clone. What? It's a problem. I have a constructor. What? Yeah. One small problem. Figuring it out. It was because I don't have a constructor. Anyway, window. Gonna delete this. Nice transform. Draw. Let's check if we get any response. No. If I, yeah, yeah. Okay. Now we're gonna implement octaves. And how do we do that? Let's start first of all with octaves. Column O from 0. Octaves O plus plus. Okay. We're gonna use assigned int octaves. C2. and we're gonna divide by octaves. We can say this times 2, but if we're dividing by 2 every time, we can just say octaves, shift left octaves. Okay, we're gonna use a float of noise to save our input. Float of scale, because we're gonna choose a smoother scale every time, and a accumulator. And now I'm gonna say noise times scale. Scale accumulator equals scale with scale, and scale plus equals noise cancelling. Let's say not plus, it's this, and float noise cancelling equals 0.25. I guess so. And now output of height times width plus x equals noise divided by f scale accumulator. Let's check. Let's say 20 minutes. Yeah, don't get any answer. Octaves 0. I set octaves. No, it's shift right. Left just doubles the number, right goes divided by 2. Okay. Right. This is actually x. Okay. Now to see everything, let's make octaves and noise cancelling changeable. We'll go here, here, event type, save event, key pressed, equals Save keyboard of Q. I just want the city change. This will air noise octaves plus plus. Isn't it public octaves? Yeah. Let's say octaves minus minus. Actually, I want this to go here. Let's check. Problem. I can actually public with assigned in details. It's quite a long video, but you can see and now I want to change the noise cancelling. Say A, E, you can see we have a Perlin noise function. But everything is running smoothly. I mean, it's not Perlin noise, it's actually value noise, so that's why it's not so smooth, but it is a map generator. Scale. Let's say I can actually make this smaller. You can say smaller changes. You can see the squares just like in value noise. You can see I'll post a better solution to this problem, but it was just to show you guys one way of doing it, and in the GitHub you'll get all the explanation how I got here, and what you do is every um, function. Thank you for watching, guys. I hope this was useful, and see you next time.